total voltage here is 125. Then your R1 is 20, your R2 is 30, and your R3 is 50. Now the first question says we should find the equivalent resistance. Since the resistors in series, we can say that R is equal to R1 plus R2 plus R3. So that is equal to 20 plus 30 plus 50. So that means the total resistance is equal to 100 ohms. That's the first, and that's very straightforward. Now the next is we should find the current from the power supply. Now the current from the power supply, since we know the equivalent resistance, we can say that I, the current from power supply, is equal to V, the total voltage, all over R. Okay, so the voltage given here is 125 volts. Now divided by R, the total resistance is 100. So it means that the current is going to be 1.25 amperes. Okay, so the current is 1.25 amperes. So that is it for B. Now the C question here says we should find the current through each resistor. So we should know that the current through R1 is 1.25 amperes. The current through R2 is 1.25 amperes. The current through R3 is 1.25 amperes, because whenever resistors are in series, the same current flows through them. The same current from the source is the same current that flows through them. Okay, so that means I1, the current through R1 is 20 ohms. The current through I1 is 1.25 amperes. The current through R2 is 1.25 amperes, and the current through R3 is also 1.25 amperes. Now the C part to that question says we should find the current, okay, the D part now, the voltage drop across each of the resistor. Okay, so we have seen that the voltage is different for the three of them, and voltage is always current times resistor. Okay, so we can say that V1 like we know is equal to IR1. I remains the same, so it's only R1. Okay, and the same way V2 is equal to IR2, and V3 is equal to IR3, like we saw. Okay, so that means since our current is 1.25, is the same, so the voltage across R1 will be 1.25 multiplied by R1. R1 here is 20, and if we use a calculator there, we are going to get 25. So that's 25 volts. Let me rub this off. Okay, so we have 25 volts. The same way with V2. V2 is IR2, so the current is also 1.25. The same current passed through them. Then R2, the resistance there is 30. Okay, and with that, we are going to get 37.5 volts. Okay, then V3 now is also 1.25. Now in this case, now multiplied by 50, and if we do that, we are going to get 62.5 volts. Another way we can do that is to find V3 is that if we know the sum of, we can also say that V3 is equal to 100 minus V1 plus V2. Okay, so which is 100 minus V1 is 25, V2 is 37.5. By the time you do this, you see that the answer is also 67.5 volts. Okay, so that is quite easy. Now the next question we are asked to find here is the power dissipated in each resistor. Now it's quite simple. Power, P can be IV, that means current times potential difference across them. Power can be I squared R, and power can be V squared over R. Since we have found the current in each of the resistor, we know the resistances, and we also know the voltage across each of the resistor. We can use any of the formula. But if we use P equal to IV, it means that P1, the power across the first ohm resistor, can be IV1. Okay, so the I is is already 1.25. Then the V1 multiplied by the V1, the voltage across R1, we got to be 25 volts. Okay, so you can multiply that with your calculator. Then P2, now the power P2 should be IV2. That means 1.25 multiplied by V2, we got to be 37.5 volts. So you can multiply that. Your answer should be in watts. The same way P3 is IV3. Okay, so that's going to also give us 1.25 multiplied by the V3 is equal to 62.5, right? And the V3 is 62.5 volts. That gives us the answer that we are looking for. Okay, and the unit of power is watts. Now we see another question. It says determine the following quantities for the circuit shown below. A, the same thing, the equivalent resistance. B, the current from the power supply. C, the current through each resistor. D, the voltage drop across each resistor. And E, the power dissipated in each resistor. Okay, so here to find the equivalent resistance, since the resistors are in parallel, how do you know resistors are in parallel? Different current passes through them. When the current I comes from the source, is split into I1, I2, and I3. Okay, so you can say I1 here, we can have here to be I2, we can have here to be I3. Okay, the equivalent resistance, we can say for parallel connection, 1 over R is equal to 1 over R1